Hello guys and welcome. This is I Play 4K, aka I Play 8K, aka I Play 16K, because guys, during this video today I'm going to show you Crysis running on 16K resolution on a single RTX 2080 Ti video card. And today I'm going to show you pretty much profiles of the 16K resolution low, medium and high. I'm going to use the DirectX 9 API because with the DirectX 10 we getting VRAM overload because it's using a little bit of tessellation, just a little bit, during the Crysis CryEngine 2 in the Crysis game. So guys, if you don't know, this is going to be the first. This video should be memorizable. So go ahead and smash that like button because this video will be the first video on YouTube of Crysis 1 at 16K resolution ever, and I'm running on a single video card. Keep in mind that I was the first YouTuber also who uploaded for you guys 12K resolution of Crysis 1 with the 2 RTX 2080 Ti. I'm also going to show you one RTX 2080 Ti in a different video in the Crysis. It's going to be Crysis benchmark, but this is going to be just dedicated to 16K resolution, 133 megapixel real-time render and single RTX 2080 Ti Turing GPU architecture, and the 6-core Core i 9th generation running at 5.3 gigahertz. So 15,360 by 8640 is going to be 132.6 megapixels. Okay, and we're going to start with the low. Motion blur will be off, and pretty much I'm going to reload the level every time I'm going to change the settings. So I just apply this. This is 16K, guys. Let me real quick go ahead and show it to you again. Where's the setting? Here we go. Okay, low, everything at low. Let's go ahead and do the single player because I really like the beginning of it, because we can use it as a benchmark when the whole team with the Prophet in the airplane, and for the future video card comparison we can use it as a benchmark. Okay, not sure what happened there. Didn't scale the loading screen, as you can see, guys, somehow. Let's go ahead and get going. Here we go. It's loading. 16K resolution, guys. This is unique, guys. This is not those copycats. This is unique content. iPlay4k.com on YouTube. I am the first YouTuber that's showing you 16K resolution in Crysis game at all, and this is on a single RTX 2080 Ti, which will be, look at this. Look at this, guys. At low, it's average 40 FPS, so it's going to be playable for the old school gamers. Very playable for the old school gamers. Delay in milliseconds by that FPS at the left top, millisecond value. Can you see that? This is the delay between the hardware, which is the GPU, VRAM, pretty much the whole video card, CPU, and the software controlled and managed by the software, which is DirectX 9 API under the Windows 10 Pro today. And it's not so high, by the way, at 16K resolution, not very high. And after 30 milliseconds and above, the gameplay becomes a little bit laggy and stuttering, but as again, for the old school games, even up to 40 milliseconds, sometimes it's still without the lag, and it's just a little bit of stuttering. But to have a perfect without the stuttering gameplay, you need to have below 10 milliseconds and kind of a little bit sometimes stuttering, 10-20 milliseconds, and above 30 milliseconds is going to be stuttering. But I'm going to go ahead and report you the whole experience right now. Today I'm running on 8K native TV plus the DSR, custom DSR. Here we go. Check it out, guys. The first 133 megapixels real-time render. So we see what the hardware is capable. Turing GPU architecture is the first GPU, guys, architecture by NVIDIA that is capable to run 133 megapixels in Crysis in real time. And I'm recording today at the same time with the ShadowPlay so you can add at least 2 FPS to the FPS counter, because the ShadowPlay is a software that is recording on the same computer, so it's taking some FPS while it's recording. Look at that. This guy's the vanilla. So I already showed you 12K vanilla on 2 RTX 2080 Ti and SLI, and now I'm going to show you vanilla. So this is without any modes, but keep in mind that I'm going to show you 16K resolution with 2 RTX 2080 Ti with the modes, and it's going to be edited video. This video is not edited, this is the way it is, and I'm commenting in real time as well. I don't feel too much of the guys stutterings, so or any lag, so it's pretty much playable. Okay, as you can see, there is no bubbles at low. Maybe, yeah, there is some bubbles, but the water kind of looking funny, guys. Looking funny for me, because guys, the Crysis that I'm going to show you over the iPlay 4K, AK, iPlay AK, AK, iPlay 16K YouTube channel, or iPlay 4K.com, it's going to be just amazing. We still have the footprints pretty much low, doesn't look too bad, but believe me, the water and everything that I'm going to show you, it's going to be on another level. The whole beach will be on another level, and the textures will be here on another level. As you can see, it's kind of pretty low quality. I believe that this is the 256 textures on this stone, but at 16K it doesn't look too bad. But when you're going to see it at 1080p, it's going to look too bad, because the objects are, you're not going to run so many objects on the screen, and it's going to appear to you a little bit bigger, and when you're going to come to it, it's going to kind of be messy. But at 16K it's not that messy. Even when the textures have low resolutions, guys, the higher resolutions like 8K, 10K, 12K, and even 16K makes this texture looks normal and okay, much more acceptable that at 1080p or 1440p, because as you can see from the distance, it's just increasing the count of the pixels and details, and it's looking okay. Even from this distance, it's almost like detailed, but it's like not detailed, it's plain. If you're going to look at 1080p, it's going to be plain. But I'm going to show you some 4K textures and 16K and 12K over the iPlay 4K. It's going to be amazing. Alright guys, over here at the left top, as you can see, I call it tougher, self-explanatory. T stands for the temperature for CPU, GPU. U stands for the utilization or usage of the components such as CPU, GPU, VRAM, and system RAM. Total system RAM today is 32 gigabytes, DDR4, 2133 megahertz, Corsair gens, and the total allowed VRAM, which is the first value as you can see under the VRAM and system RAM, is 11,000 megabytes. But somehow after 10 gigabytes, same thing like under the GTX 1080 Ti, Pascal GPU architecture, when it's reaching above 10 gigabytes, the video card is acting weird. It start showing you kind of high millisecond delay and stuff like that. So maybe NVIDIA is faking it over there somehow, and that memory is not as fast as the other memory before 10 gigabytes buffer. Who knows? But 30 FPS guys, and a little bit more than that without the recording will be 35/40 FPS average. Unbelievable result. Video cards are synchronized. VRAM is overclocked by 1200 megahertz as you can see on GDR6, because 14,000 megahertz without the overclock and 15,200 with the overclock. GPU are stock. Look at that CPU usage, very low CPU usage at 16K, and CryEngine 2 consumes a lot of CPU. Alright, let's go ahead and restart it. I'm going to go ahead and quit it, and now we're going to try Jesus, I forgot to show you the resolution for those non-sayers. But anyways, believe me guys, 15,360 by 8640, 133 megapixels. Now we're going to go ahead and switch to a medium. Everything at medium. Motion blur is off, but motion blur at medium or off, it doesn't make any sense. But just because I'm recording, I want you to see those, you know, those differences at 16K versus the 4K, even if the video will be recorded at 4K, because this is not the pixel comparison. Even Monkey knows that there is a difference between 4K and 16K. This is the message to the non-sayers, to those haters. But We're not comparing the pixels. Today we're comparing the performance. We're looking at the performance, at the numbers at the left top. So this is the computer science video, okay, to demonstrate us the technology improvement. Look at this, now it's scaled, right? And this is what it's all about. And okay, medium, guys. As you can see, the GPU is not fully utilized, and pretty suck. And I believe this is due to the CryEngine 2.
Hey, Nomad, you still with us?
This is the nature of the CryEngine 2, because some of the components that they use in the CryEngine, like some shaders, not all shaders, but some shaders, not utilizing GPU correctly, not loading instructions on the GPU, it's loading instruction on the CPU. So it's kinda, but right now 100%. So it's kinda, guys, balancing it out. But right now 100%, but it's not going to stay 100%. It should stay 99, 100% almost everywhere, but it doesn't do that. And I believe it's not just because our GPU is overloaded, kinda. It's not like that, because otherwise it would be at 100% load. As you can see, that value after the temperature is our GPU load, as I already told you, usage or utilization. And keep in mind, guys, that second video card in SLI is disabled. Even if I do have two video cards, but second video card in SLI mode is disabled. So SLI mode is disabled, and the first video card doesn't have no air to breathe, because the second video card, as you can see, is installed. So your temperatures will be like below than that. Your temperatures will be below than that. And if you're running, as I'm running today, a single EVGA during this benchmark, single EVGA RTX 2080 Ti XC Ultra, if you're running it, your temperature will be like 72 at maximum load. If you're not going to have a second video card installed, that's going to pretty much not allow the first video card to breathe, or breathe the first video card hot air. And this is what happens right now, even if the second video card doesn't work, but it doesn't, there is no space for the first video card to breathe. And I'm apologizing, but as again, you need some space to overclock it. We still could overclock it to 2000 megahertz on our GPU, and we already overclocked the VRAM. So maximum what we could increase about 2 FPS maximum, because the CPU is overclocked to 5.3 gigahertz, as you can see. And as again, this is vanilla, guys. This is Crysis vanilla at 16K resolution, and maximum Crysis with the maximum modes, beautiful textures, beautiful visuals is coming over the ShadowPlay4K.com. So as you guys look at that VRAM usage, 7 gigabytes VRAM usage, not so bad. So Turing GPU architecture consumed 2 times less VRAM than Maxwell GPU architecture. This is for sure, guys. So NVIDIA compressing more data before it's storing into the frame buffer, into the VRAM in real time, compressing more data than under the Maxwell GPU architecture. And I believe it's 1.3 times, and sometimes even 1.5 times less data compressed when we're comparing with the Pascal GPU architecture. But when we're comparing to Maxwell GPU architecture, it's definitely 2 times a little bit. Let me see. Yeah, it's playable, guys. I mean, it's playable, but as again, you can feel that 22 FPS. So there is kind of no stuttering, but just because low FPS, it's kind of lagging out due to the FPS. But there is no stuttering like stuttering. It's just due to the FPS nature, 22 FPS. Look at that delay, below 20 milliseconds. So if we could have more CUDA cores to process it, with the Titans it would be a little bit higher than that. Just because the low milliseconds in delay, it's not going to be stuttering at all, and 30 FPS should be clean. Pretty much, as you can see, at all the time. 94%, as you can see, 96% scalability. So I believe it's nature to the CryEngine 2, which is not the best engine when it comes to Crytek company. The best was, I believe, CryEngine 3, the version 3.6 that they use in Crysis 3, because Crysis 2 CryEngine was kind of suck. when it comes to SLI utilization. CryEngine 2 was great, as you can see, in utilization of the SLI, almost great. But Crysis 3, CryEngine 3.6, I believe, the best Crytek engine. And CryEngine 5 is kind of suck for SLI as well, because Crytek company removed a lot of licensed content, a lot of licensed classes, dependencies, and so they could make it as open source, and they pretty much kill its company, kill its beautiful engine that was able to do all these beauties. So CryEngine 5, not so beauty. Alright guys, as again, was the medium. Okay, you saw the FPS 22 kind of average without the recording, probably 25 average, but you cannot play it even in single player without the computation like that. So low is playable, very playable by the way. Medium is not playable, but let's go ahead and have a look at high. As again, I'm running DirectX 9 because DirectX 9 API, because DirectX 10 API is overloading our VRAM, and it's available very high with DirectX 10, but it's not going to run that. Okay, but object quality is still at high, guys, as you can see. So keep that in mind. So you can increase the FPS if the object quality will be decreased. But I decided to keep object quality at high, at maximum possible details with DirectX 9. So it could be increased by 2 FPS as well. So I'm going to go ahead and as again log out from the game, and we're going to change the resolution, and we're going to load the game again at the high settings, and I'm going to go ahead and wrap it up. And as again, guys, the first 16K resolution video, amazing, amazing, guys. Don't forget to smash that like button. I was so impressed when I was testing it. I don't have that emotion feeling right now, but I probably will when I'm going to play with the maximum visuals, when all the kind of goodies and modes and high resolution textures and improvements and shaders, and I will show it to you guys. But as again, not during this video. This video is about the vanilla, because we want to test vanilla, because when I'm going to put all the modes, you cannot duplicate it and test it on your system to find out how fast this system today with the Core i9 9900K overclocked to 5.3 gigahertz or 5300 megahertz with the 2 cores disabled in the BIOS, and hyper threading technology is disabled in the BIOS on the motherboard Asus Maximus 11 Hera Wi-Fi model. Alright guys, at high, look at that milliseconds delay. Ooh, GPU is struggling. So the whole GPU architecture is struggling. Even if we will put more VRAM, we're still going to struggle. We need to put as well more CUDA cores, so those CUDA cores will be utilized. But as you can see, we're not utilizing 100% of our GPU, so there is a possibility that it's not only the utilization of the whole CUDA cores, I think it's the GPU architecture. So I don't think the Titan RTX Turing GPU architecture, which is with a little bit more CUDA cores, will show you 15 even FPS here. Maybe it's going to show you at the same settings 12 FPS under the ShadowPlay recording, and that's going to be about it. But delay in milliseconds will be the same, because as you can see, it's not utilizing all the way the CUDA cores. So it means that it's not about just the CUDA cores, it's just managing under the DirectX 9 API between the hardware and the software, and those between the GPU, CPU, VRAM, system RAM, all this managing data. And especially it's mostly that delay, latency delay is between the GPU, VRAM and DirectX 9 API, but as well CPU plays some role as well, just a little bit in 1-2 milliseconds, but not too much. But mostly GPU architecture showing how fast the delay between the hardware and software, because that delay is between the GPU, VRAM and the software DirectX 9 API. So it's showing the distance traveling between the GPU and frame buffer, and it's controlled with DirectX 9 API. It's just beautiful, guys. Look at this. It just now it's amazing with the particles and stuff like that. But 10 FPS, 11 FPS is better than a slideshow, and this is the first GPU architecture that allows us to see and it's incredible, but it's not there yet, as you can see, with a single RTX 2080 Ti video card. So technically we should be here about 20, even maybe even more, if we're going to utilize at 99-100% our SLI, probably 25 FPS, but we're going to find out. And I'm going to show you guys with two RTX 2080 Ti. But as again, look at this, all the details, looking amazing, guys. Caustics, oh my goodness. Delay 90 milliseconds, so pretty sure it's going to be stuttering, guys, at 16K resolution. So pretty much delay is high, means I think that GPU is probably struggling to push the frames. It can push 16K resolution, as you can see, full palette with all the processing and instruction processing and shaders through it and textures and all the data and storing at the same time into the VRAM frame buffer, but it's still struggling. I don't think that delay is because our GDR6 VRAM is slow. I think it's just the GPU architecture is not capable. I'm pretty sure if we will be using the faster VRAM than GDR6 in 2020 with the same GPU, we're not going to cut it. I don't think it's a delay in a data storing between the, look at that, between the GPU and VRAM. I think it's just GPU pipeline not capable to push enough and process enough instructions. Beautiful, just beautiful, guys. And look at this, at 16K resolution, not detailed textures, looking almost detailed. So this is, guys, what the beauty is. You can run the low resolution textures, but at the 16K resolution, they're going to be looking sharp. And this, guys, keep in mind, this is not even 1024 by 1024 texture. It's just probably maximum 512 pixels by 512 pixels. But look how nice it is, because the objects is kind of smaller. They appeal smaller, and we can show more details rendered on our screen, because this is 16K resolution. It's higher resolution. Beautiful, beautiful, guys, absolutely amazing. This is just amazing. And as you can see, I also put for you the CPU cores utilization for one of those goblins that doing it. They just copycats, they just putting bunch of numbers without the explanation. But as you can see, everything is explained. My CPU today is water cooled with the Corsair H150i Pro. It's a hybrid water cooling system, and 100% fan rotation on the EVGA RTX 2080 Ti XC Ultra. It's a dual fan video card, the cheapest EVGA dual fan RTX 2080 Ti. And guys, you don't need to buy top of the line RTX 2080 Ti. Buy the cheapest one, save yourself a box. Buy the cheapest DDR4 system RAM and invest money, and buy the core. If you're looking at the 9th generation Intel CPU cores, buy yourself i5 9600K for games, for video encoding, for 3D rendering. It's more than enough, guys, trust me. I do all of this. I'm a professional 3D artist as well. I'm a graphic artist as well. I'm a programmer and a YouTuber, which is encodes videos as well. Alright, guys, you saw the FPS, and yeah, 16K resolution. Let me real quick go ahead and show you again the resolution, and I will try to attack that guy because he's gonna generate more particles. Let's go ahead and try it. And he's gonna stress some CPU as well, because it's going to be AI looking for pathfinders. But look, it's running without delay. It's running nice. You can see the sprites is a little bit not at that level yet. So sprites probably using like maybe 128 by 128 pixels, and it should be improved. Hopefully the modes will improve the sprites, because I can see the sprites is not at the level yet. I can see the noise. I can see the noise, guys. You can see the noise on the sprites. Can you believe this? You can see the noise. This is power of Crysis, guys. The noise on the sprites. The noise on the sprites at 16K resolution. Alright, guys, I showed you everything. Let me real quick go ahead and close it, and I'm going to real quick go ahead and show you the system specs for non-sayers, for haters, and for some people who's curious. But as again, buy yourself Core i5 9600K, overclock it above 5 GHz. Buy yourself the cheapest DDR4 system RAM. Buy yourself the cheapest from EVGA, Asus, Gigabyte, or MSI RTX 2080 Ti. Make sure it's at least with dual fan. If the price will be the cheapest with triple fan, buy yourself triple fan. You're going to be good to go. RTX 2080 Ti single at 4K resolution, and later on you can add the second one in SLI. But for SLI you need the first video card on a hybrid water-cooled system. So, and they selling them about $50 more, $70 more. Buy yourself an SLI, first one on hybrid water cooling, because you're going to struggle under the temperature. And if you will buy the first one, you don't need to have both of them, as this is the video cards. You don't need to have both of them, guys, on water cool, on a hybrid water cool. But buy yourself a first one and connect them with the bridge. You're going to be a Gucci, and you will never reach in SLI temperature above 70 with 2000 megahertz or 2 gigahertz overclock on GPU, and you will be probably 2 FPS higher that you saw today. So 5300 megahertz or 5.3 whopping gigahertz with 53 multiplier as external frequency. I also use the 50 multiplier, which is 5000 megahertz or 5 gigahertz on the AVX instruction frequency. 6 core hyper-threading disabled, so 6 core, 6 threads. As again, motherboard was Asus ROG Maximus 11 here, Wi-Fi model, Z390 chipset. Okay, I have that there, guys. This is what happens when you installing on ROG Maximus 11 here. 16 gigabyte DIMM. Do not ever do that. Even if motherboard supports 64 gigs, do not do that, because with the Corsair, or maybe just the memory, but Corsair Vengeance, I believe it has problem with RQ with my USBs. All USBs, guys, even if I'm using all the ports, they're all working, no problem, not a hitch, because all the hard drives connected to it. And even without the USBs, it's showing there, I believe. But when I'm installing 8 gigabyte DIMM in the DIMM slot of DDR4, there is no such error. But I sold my DDR4 and I'm looking to buy a very fast DDR4 to show you, even faster than I used to have, 4500 megahertz. I'm going to show you what is the best, and I'm going to show you a technical video when it comes to DDR4, so you don't want to miss it over the iPlay4k.com. Today you watch your uncle iPlay16k. Go ahead, smash that like button. And as you can see, CL13, this is what I'm advising you to buy. Corsair Vengeance 2133 megahertz, because you gotta multiply it by 2 this frequency. And as again, 2 video cards, but SLI disabled. This is the single core performance, amazing. After the BIOS update, guys, I received a boost on the multi-threading multi-core performance by about 3-4%, which is nice. So from 300-550 we went to 36-2080, but almost the same score on single threaded performance. Keep in mind that this is going to be the best performance on a single core, single thread, and newer Intel CPUs at stock will never reach my overclock performance in this CPU Z test, which is 11.01.64. If you can, go ahead and pause the video. Alright guys, as again, you watched the Uncle iPlay16k, www.iplay4k.com or www.iplayak.com or www.iplay16k.com. Smash that like button, and I will see you in the next videos. Right now I'm putting those cool videos for you to check out. Don't miss them out. Positive comments. If you're watching it through the premiere, go ahead and ask some questions, and I will see you in the next session. Till the next time.